Good morning, students. Today I will be discussing a little bit about physical and chemical changes. This is chapter 2 from class 8. So remember this thing, there are many changes occurring near around us, right? They can be physical also, they can be chemical also. But before discussing about physical and chemical changes, we must know about reversible and irreversible changes. What are reversible and irreversible changes? These changes which can be reversed by reversing the conditions, right, are reversible. Which cannot be reversed are irreversible changes. Those who can't be reversed are generally chemical changes. Those who can be reversed are physical changes. However, some of the chemical changes can be reversed, but maximum chemical changes cannot be reversed by reversing the conditions. Like this is the physical change. Here solid is converted into liquid and then liquid is converted to gas. Means heat required. For example, ice is there, heat is required, it changes to liquid, means water, and then heat is required, it changes to vapor. But if you want to cool down vapors, then means convert vapor to liquid, then you have to cool them. And if you want to change liquid water to ice, then you need freezing temperature over there, right? So this is just a introduction related to reversible and irreversible changes, right? I hope that you have understood, right? Okay, then there is a one simple activity related to the sugar, that some of the changes can be reversed, some of the changes cannot be reversed. But before that, I will tell you about the curdling of milk. Curdling of milk is a chemical change, because once the milk is converted to curd, it will never return to milk again. Once the food is being cooked, it will not be returned to uncooked food again. It is a chemical change. But suppose if you are melting something, it can be frozen again. So this is a physical change, sorry, right? So curdling of milk, chemical change, because it cannot be reversed, right? Digestion is a chemical change, photosynthesis is a chemical change. Similarly, burning of fuel is also a chemical change, right? So instead of reading from here, I will directly tell you from here, right? Clear? So I will be telling you from here, right? This is the sugar, right? If you heat the sugar, it will change slowly to black sugar charcoal, and this will never be converted back again to sugar, right? If you will add lemon to milk, it got this curdling curdling of milk happens here, so it will not be returned to milk again. Now we will be discussing shortly periodic and non-periodic changes. What are periodic and non-periodic? Periodic changes which occur after a regular intervals of time. Non-periodic changes can occur anytime. Like for example, seasons are there. Like now these days it is summer. So next year also in the end of April there will be summers, right? Similarly, pendulum is also under a periodic change. What are non-periodic changes? For example, there will be a rain, maybe say after 1 week. There not be a rain next year same date, right? So floods, volcanic eruption, earthquakes are non-periodic change, right? So periodic changes occur after a regular interval. Now I will be moving towards desirable and undesirable changes. Desirable changes are those which are useful to us. Undesirable changes are not at all useful to us. Undesirable changes, we got earthquakes. We don't, nobody like earthquake should be there. Nobody like flood should be there. Yeah, thunderstorms will be there, right? So volcanic eruption, these all are undesirable changes. Whereas desirable change is, right, ripening of fruit, growth of human beings, right? These are desirable changes. Yeah, cooking of food is also a desirable changes. Now we are moving towards physical and chemical changes. Glowing of a bulb is a physical change, right? Clear? Glowing of a bulb is a physical change. Similarly, thermal expansion of a substance like wires going from one pole to another in electricity poles generally hang in summers and contract in winters, right? So that is the thermal expansion of a substance. This is also a physical change in a state of matter. We have just discussed previously in this video also. This change in state means from solid to liquid, liquid to gas is also a physical change. Means kinetic energy is involved over there. In gases kinetic energy is highest, in liquid it is less, and least in solids, right? Okay, so this is over. Now we are moving towards another type of physical change, that is sublimation. Sublimation is also physical change in which a solid directly changes to gas. And what is deposition? Deposition when gas directly changes to solid without having a state between, that is liquid. Then there is dissolving of a substance in a solvent, right? And when a solute is dissolved in a solvent, solute, suppose salt is solute and water is solvent, both mixed together, they will change to solution, right? Okay, and then we will move toward directly towards chemical changes. What are chemical changes? A chemical change are formed which cannot be reversed. A new substance is formed in a chemical change, right? Clear? Very few chemical changes can be reversed, otherwise maximum chemical changes cannot be reversed. For example, burning. Suppose you are using fuel in your cars, bikes, and that cannot be reversed back because new substance is formed. Once a candle is being burnt, it will never be brought back to candle again. Once a food is being cooked, it will not be returned to a normal food, right? Coal burnt in homes during winters, it will not be returned back to coal from the ash. Hence these are the few examples of chemical changes. Now we will be moving towards rusting. Direct rusting means, see this is the diagram of rusting in iron rods. Yeah, iron chains, there is rusting. Iron is gray in color. When rusting occurs, it will change to what? Brownish powder like this, and it will not be a same substance because before uh, before formula of iron is Fe, but after rusting its formula will be Fe2O3 dot XH2O. This will be the new formula for rusted iron. This means X here means number of water molecule. It will be varying from substance to substance, right? Sorry, it will vary from area to area, means where moisture content will be more, X number of water molecules will be high. Where moisture content is less, number of water molecules will be low, right? Curdling of milk, again a chemical change. Charring of sugar also we have discussed, it is also a chemical change. Digestion of your food in your stomach is a chemical change. Similarly, fermentation is also a chemical change. Fermentation means with the help of fermentation there people make enzymes, alcohol, right? So photosynthesis, plants make food in the presence of carbon dioxide, water, and green color pigment. Chlorophyll in the presence of sunlight is also a chemical change. Respiration, when you take carbon dioxide and you will what I want to say, that when you take oxygen from the plant and you will give out carbon dioxide, that is a chemical change because a new substance formed, right? Okay, then conservation of mass in a chemical change. Remember this thing, there is a conservation of mass, means mass doesn't changes. People see from outside only that a candle is burnt, its size decreases, that means mass changes. But reality is that on burning candle there is production of carbon dioxide plus water vapor. If we calculate that also in the mass, then there is no change in the mass. This is law of conservation of mass, right? Mass can neither be created nor be destroyed. These are the physical and chemical changes given in your book, and you can read it. However, we have already discussed these things also in the class. Now I will be taking your consideration to exothermic and endothermic changes. Exothermic changes are those in which heat is released, right? And endothermic changes are those in which heat is absorbed, right? So directly we will be going towards the example of exothermic and endothermic changes. Let's see, this is the endothermic changes. right? Endothermic changes are those, for example, cooking of food is a kind of endothermic change, because in this no heat is released, right? Endothermic changes are those once the supply of energy is being stopped, endothermic change will stop there itself. For example, when you are cooking a tea, you're cooking a food, and in between you switched off the gas, then food will not be cooked properly. In this there is an example of a formation of nitric oxide. Nitric oxide generally forms in the cloud when lightning is there, because nitrogen and oxygen is already present in the atmosphere. So when lightning occurs, nitric oxide is found. But hot sunny day, no nitric oxide is found, because no clouds will be there and no thundering will be there in the uh, sky. So electric spark required for this reaction. Similarly, now exothermic reaction, in this heat is released. Heat is released, for example, when a fuel is burnt, right? Once the car started, it will automatically start burning the fuel. A piece of coal is started burning, it will burn completely, mean it will continue to release lot of heat. Similarly, many other reactions are also here. Iron and sulfur filings, is iron filings mixed with sulfur is an exothermic. Once you start heating it, it automatically mixture get heated, right? And they both mix together, right? This is also a exothermic reaction, because if in this reaction, if you stop heating it also, if you stop heating, you will find the solid continue to glow in this case, right, throughout the mass. After the glow dies out, the test tube get cooled down, and you will get grayish black solid, which cannot be returned to iron and sulfur again, because it is a new compound that is called as iron 2 sulfide. So this is also a exothermic change. In exothermic changes, heat is being released. In endothermic changes, heat is being absorbed. Thank you and have a nice